Mau diliatin EVE-nya kan?
Ini kelihatan?
Kelihatan. Kelihatan. Coba aja lihat lihat.
Boleh.
Udah. Lihat Bu. Lihat aja.
Alright, welcome back to 40-Day Pilot Academy. We're going to discuss about drag and more subjects related to the aerodynamics. In the previous chapter, we already talked about what is lift and how we control the lift as a pilot. Now let's talk about drag. What kind of drag that we have? We have several drags to consider. The first is the parasite drag and the other one is induced drag. So the easiest way to remember about the type of drag is when we talk about the parasite drag is the byproduct of the speed. Okay? And if you talk about the induced drag, is the byproduct of lift. The parasite drag is that not associated with the production of lift. There are three types. The first is form, interference, and skin friction drag. So the skin friction drag, if you see the airplane skin is never smooth. Sometimes there's like a ball and there's like frictions, the contour of the skin. And especially on the wing, sometimes they put that intentionally to give energy to the airflow, okay, to make sure that the boundary layer purpose is they put some texture or contour on the airflow to help the laminar flow to extend, give energy to the airflow. So that's the skin friction of the drag, and then we have interference, and then the form drag. You know, like form drag, interference. We have like wheel, and then what else? You have landing gear, right? You have landing gear, and then a lot of antennas. So that's all parasite drag. It means if you are talking about the parasite drag, let's imagine you are driving a motorcycle, then you bring a box of pizza. If you do this, the box of pizza, there is no drag. But if you put like this, the 90 degrees, and you just put the box of pizza in front of you directly, then that will face directly to the air molecules. Then you will have like 100% drag. So the parasite drag, the higher your airspeed, the higher the drags. And the induced drag is produced when the wing produces lift, for example, like wingtip vortices. So let's find out what is the relation between parasite drag and the airspeed, and what's the relation between induced drag with the airspeed. You can find out now. How many times increment of the Alright, you should find it. Come on, let's find it. Google it.
I've already questioned parasite drag relation between parasite drag and airspeed.
Yep.
It was already two times. So if we double the airspeed, 4 times.
4 times greater,
Yeah.
right? And then how about if you reduce the airspeed?
So just divide 2.
No. Anyone?
parasite drag varies with the square of the airspeed.
Square of the airspeed, so more. What next?
Parasite drag is highest at high airspeed.
And?
The total drag is the sum of the induced drag and the parasite drag.
Okay, you find out about the relation drag and airspeed.
The relation.
Yeah, if you double the airspeed, what happened? And then how about the induced drag?
For the induced drag.
When the airspeed doubles, the parasite drag fourfold.
Fourfold, yes.
Per time.
And then?
When
Yeah.
it's decreased, right?
What is decrease?
Wait.
So remember, parasite drag, if you increase double the airspeed, that's 4 times on the parasite drag. And how about the induced drag? If you reduce the airspeed,
Decrease.
how about the drag? The drag increase, of course.
The parasite increase.
No, the induced drag, right?
Induced drag. Induced drag. Oh, so if we reduce the airspeed, so the more the vortex, right?
What?
Because the induced drag.
Go on, find out first. Well, so remember, the parasite drag, if you double the airspeed, the parasite drag will 4 times greater. Okay? And you got the other one is the induced drag is by produce of the lift. Then that will give you lift. Then that will give you, the more you increase the lift, the more you get the drag. That's why flaps, since flaps is high lift device, so by putting the flaps, what's gonna happen, you will have the another drag, right? Okay. So now let's talk about the drag itself. What is this? This is the
parasite drag.
This is airspeed and
That's drag.
drag. Yeah. So it means the more the airspeed, the more the drag. And how about this?
That's for
Induced drag.
induced drag. Lower the airspeed.
So this is the induced drag. The lower the airspeed, the higher the drag. And what do we have now? Here is LD max.
Ultimate is at the total drag line.
Sorry.
Not there.
This will be the minimum drag.
Yeah. The LD max is with the total max line. Yeah. There.
This will be your LD max. Okay.
Yeah.
So this is your minimum drag. It means at this point, this is all about speed. At this speed, you got very little of drag. And this is your total drag.
No, that's total.
And this is the Fiji. Okay. So what's Fiji? Is best
Glide speed.
glide speed. Why do we care? If you have engine failure, what's gonna happen? Then you have to fly exactly at that speed. If you fly exactly at the Fiji or the glide speed, then you have the minimum drag, and that will be your lift to drag ratio at the max point.
And get the best performance.
What is the best performance? It means you have the best glide ratio. Let's say you have every 1,000 altitude losing, you travel 1.5 miles distance. So that's a ratio 1 to 1.5. That's why if you have engine failure, what's going to happen is there's ABC checklist, ABCD checklist. The A is you have engine failure, pitch for the VG. The Cessna is 65, the PA-28 73. In the Duchess, right? Every airplane is different. Duchess is depend on the weight. Maximum, not maximum, it's more than 3,000 pounds. It's 95. 3,000 pounds or below is 82. So you have to memorize that, because if you're flying at that speed, you will get the max distance.
In engine failure,
Yes, in engine failure.
speed 70 kis.
What kind of airplane is that?
PA
Yeah, 73, right?
73.
Yeah, 73. Yeah. PA-28 is the glide, or Fiji is 73. So why do we care about Fiji? Because we want to get the highest horizontal descent that we get every 1,000 feet altitude losing. Why? So that because you have lift to drag ratio at the max, and then you're at the minimum drags. Now, let's take a look. We extract this total drag. Okay, this is another drag, and this is power, and this is speed. The things that you have to think in the airplane is not like a car. In a car, when you want to add speed, what are you gonna do? You put the gas, right? I mean, you put the accelerator, which is that your pedal. In our airplane, the accelerator is your throttle, the propeller. So when you add more power, you get more speed. How about in the car, if you want to reduce your speed, what are you gonna do?
Just push the brake.
Or just release the power, release the pedals. Then it's decreasing, like 50 mph, it's 40, 30, 20, boom. But in the airplane,
Pulley.
wait a second. At a certain speed, you want to fly at really slow airspeed, you have to add power. It's kind of weird. Do you get it? In the car, you don't do that. You want to slow down, you just release the pedals, then you get slow cruising speed for the car. But in the airplane, if you want to fly at certain very slow speed, you have to add power. That's what we call slow flight.
I think I get it because I ever tried once in simulator. I think
So what we call that?
Region of reverse.
Yeah, that's a region of reverse command. So this is the maximum. This is total power,
Okay.
and then after is max power available. Okay. No, right? Okay, so that's the graph. This is the max power available, and then this is total power. This is power per percentage, and this is airspeed. So let's talk about this. Right? And here, the curve. Over here is region reverse command, and this is region normal command. At region of reverse command, if you want to fly at lower speed, you have to add power. If you want to fly at higher speed, you don't have to add power. That region of reverse command. And region of normal command is everything normal. Let's talk a little bit about this. So this point is the maximum speed that you can go, and this is the lowest speed you can go. If you want to fly at this lower speed, you see this? The lower you want to fly, the more power you need. At this point, the higher speed you want, the higher power you need, right? But there's a curve to show you what is the max power available. Then the intersection point, that will be your maximum. Because at this moment, you cannot go beyond the limitation. You already put maximum power, and your RPM is already at the red radio. You cannot go even faster than that, unless you have to change your engine, right? Then this is region of reference command. The moment that when you want to fly at slow speed, you have to add power. 2, what's the keyword? Maintain what? Altitude. So the key is maintain altitude, fly at high speed, or fly at a low speed. At the region of normal command, always remember pitch for speed, power, altitude. This is for region of reverse command. And here. At the region of normal command, pitch for altitude, power for airspeed. This is really deep understanding. A lot of people think power for altitude, pitch for airspeed. Yes, that happened in the region of reverse command because you need power to maintain the altitude. You cannot maintain the altitude with only the pitch. You need power. But if you're flying a region of normal command, then you can do using the pitch to control altitude and power to control the airspeed, especially when you're flying ILS, flying with the jet. When I fly the jet, okay, I'm on the glide slope, following with the fixed constant descent rate. My pitch will control my altitude to follow the glide slope, right? And my airspeed, I control that with my power. So you will think about that. That's about the drag. So why the induced drag? How the induced drag works? The induced drag works by the production of the lift. I will show you why, right, after this. And then we have parasite drag who increase with the speed, right? Then in the middle, the intersection, we call that the minimum drag, which is that gives you the speed. What we care is when we have engine failure, the first thing pays for the Fiji. The total drag is become how many percent of the power and the airspeed. You got that intersection. You know that there's a region of reverse command, and you also know there's a region of normal command.
But in Cessna 172,
65.
oh, this one 61. With flaps up, yeah, but with flaps down by 60. Is it that different?
Yeah, because you have like a little bit lift.
Oh,
Because if you fly like 65, right, and 60, you got flaps 10, then you can fly at the lower airspeed.
yeah.
Then the configuration changes. Okay? So that's about the drag. Now, how can the induced drag form in our flight? There are two reasons. The first reason why the induced drag happens is you have the rearward component of lift. So this is the lift, and when you climb, you put more brake pressure. This is your new lift, right? And then you have backward component of lift. That is your induced drag. The first is backward component of lift, and the second one is the wingtip vortices. So as you know, you have the wing. Okay, let's use this. Wingtip vortices, the flow of air result in spillage over the tips, thereby setting up a whirlpool air called a vortex. and we call that a wing turbulence. So if you can see, this is all about the ground effect, I think, but we can also use this. So this is the wing, high pressure, low pressure. The more lift you get, the more high pressure, right? And what happened is the flow, the airflow, since you see there's a wheel at the back of the wing, right? And then it's transferred from the high pressure to the low pressure, is raising up and go to the center of the lift. You know what I mean? So this is the wing. Since this is a high pressure and this is the low pressure, okay, and this airflow from high is going up.
Oh,
Okay, and at certain point, because the airplane is moving, then it stops here and it's become turbulence back. Boom. So it's going up and then going back again. It's become a drag. That's what we call the induced drag. What is induced drag? Drag by production of the lift. All right. Any question?
no.
That's what exactly your examiner is gonna ask you. Okay. Let's talk about left turning tendency. You done with this? Good. Why the airplanes has a left turning tendency?
Because it's a single engine airplane.
Multi-engine airplane, they also have left turning tendency in a critical engine. So
Because there is for
there's a P factor,
P factor, slipstream,
torque effect, right?
yeah, slipstream, and gyro.
Slipstream what? Spiral, slipstream, remember?
There's two types.
Spiral
Slipstream
and
the gyro.
gyroscopic, right?
Yeah.
But this only for tail wheel. So what is the P factor? The P factor is left turning tendency created by the propeller, because you know this is the descending blade of the propeller and this one is the ascending blade of the propeller. And then the descending blade of the propeller, we have the what we call aerodynamic twist on the propeller. Then the descending propeller will get more air, right? More, it's higher angle of attack at this side. Then it gives you more thrust from the right propeller. Okay.
The plane like this way. So the
Yes, when your airplane is going up in the higher angle of attack and climb, so the P factor, we call that the P factor, is only when your airplane is climbing. So when your airplane is climbing, there's more angle of attack from the descending blade of the propeller. So let's remember why the left turning tendencies happen on the P factor, because there is a higher angle of attack from the descending blade of the propeller when the airplane is climbing. Okay? And that will give you left turning tendencies because there's more thrust from the right propeller. So what sensation? What kind of forces that they produce? Yaw. And how to compensate that?
use the
Right rudder. And when it's happened, high angle of attack, high power, and
slower speed.
slower speed. Right? High angle of attack, high power, slower speed. Now, our torque.
Torque is because
Ivan, what is torque?
because the reaction of the propeller.
No. All right. So, Afjal, what is the
torque is the moment when the propeller is from the propeller. When we give one direction, there's will got an action. So when the propeller
All right, let's make this quick and very clear. Okay, torque effect is the action reaction, the Newton third law. So since the propeller moving to the right, the counter reaction will be another force to the left. Moving to the right from where? That's your examiner going to ask.
from
From the cockpit.
the cockpit is
Moving to the right.
right.
Yeah. Okay. If you're looking at from the cockpit, the propeller is moving to the right, and then the counter reaction force is left. That's why it gives you a roll sensation. It's not yaw, but roll. So the P factor plus the torque effect will give you yaw and roll. See that? Yaw and roll. What's gonna happen if you have stall and not coordinate? Then you get into spin, and spin is like this. Okay, and the other one is the left-handed tendency. This is the spiral slipstream. It's moving to the right. Okay, then it's going down. See this?
Yeah,
Moving to the right, going down,
and hit.
then move and hit the left rudder and twist the nose to the left. What kind of force that you have? Yaw. So you got 2 yaws, 1 roll. It's the perfect combination to a disaster if you're not realizing the left-handed tendencies, not getting coordinate, you are skidding, because skidding is most dangerous uncoordinated turn, right? Skidding, you got skid, you got yaw, and you got roll. Then what's gonna happen if the other wing stall first? Let's say, okay, flying like this, right? You got stall, critical angle of attack exceeding. When you got stall, one wing stall first. Let's say it's this wing stall first. Then lose the lift, it's going down. This airplane has a yaw and there's a roll. Let me repeat. Higher angle of attack, exceeding, separation, airflow. Left wing stall first. You have yaw, you have roll. So what is this? Spin. This is spin. How to recover?
There's spare.
What is spare?
Power
Idle. What else?
and airspeed. No. Wait.
What is spare?
Either neutral.
What is neutral means?
You pull the neutral the yoke.
Neutral the yoke and put it to center, right?
Mm.
And then
Rather opposite.
rudder opposite. So what rudder you have to kick?
At first to the speed.
Spin.
Yeah.
The
So what?
opposite. So if
So here the airplane.
so we need to use the right rudder.
Right rudder.
Yeah.
Right? Kick the right rudder until it stops, and when it stops, it started like this. I did my spin training on Citabria. So, boom, stop, and what is the E?
Elevator down.
Just release to break the stall when the airplane like this, getting to the airspeed, and then you
Pull.
pull. And the G should not more than 2G. So we have the G indicator is accelerometer. Yeah, that's the name of it. Accelerometer. Accelerometer. Yeah.
It's in the aircraft.
Yeah, it's in the aircraft. It's for aerobatic airplanes, so Citabria has. Remember, so let's do it again, okay? You're flying, you're get distracted, your airplane stall, your left wing gets stalled first, start turning, since you're at high angle of attack, you got yaw, you got roll, you got spin. And
Power idle.
Airplane
Either neutral.
Rather opposite.
Rather opposite.
Elevator down.
Elevator down, break the stall, and recover. This is a fail item. You cannot forget like that. You have to remember and always remember, because once that happened to you, this will save your life. So you know when its spin happened, you will lose at least 1,500 feet per minute, at least, or 2,000. And how many stages of the spin? Let's find out. The first is incipient spin. Find out about the spin.
Three.
Yep. What else? What are they? Incipient
Fully developed.
and
Recovery.
recovery spin. Good. And
What?
incipient spin. That's the first entry. Full develop. Out and then recovery. Full develop is the auto rotation, same. Okay, there are 3 stages of the spin. The examiner may ask you. Most of the examiner will ask you that. So you have incipient spin, you have full development,
And recovery.
and recovery. Any question?
No. How if the stall happen in near the ground, like 2000?
It's fine, 2,000 is fine, but when you want to practice the stall, that must be at least 3,000. That's on the ACS standard.
So 3000 to do the spin.
Yeah. No, you don't train spin.
No, just for good to know.
Sorry.
Good to know.
No, you cannot train spin at all.
For what stage? For speed?
CFI.
CFI.
CFI, then you have to use this approved airplane for spin.
Oh,
Not every airplane can do spin.
acrobatics.
Yeah, like aerobatic.
So what happen if like ordinary plane goes
What do you think?
structural damage?
Yeah, structural damage. A lot of G because it's beyond like maybe beyond 4G. If you cannot make a correction properly, then maybe you lose your wing. When I did my spin, you can also do a spin training. It's fine. So you just find I can teach you for spin because you have to. Yeah, as a flight instructor, you have to get a spin endorsement, spin training. Then you have to be able to teach your student to recover from the spin. And when you do spin, you climb like 5,000 feet, and then you do a spin. So you will never become flight instructor then.
Yeah, later. Not in detail.
Is that fun?
Huh?
Is that fun?
No, that's fun. You
Just like when you in roller coaster.
yeah, but it's really fast and a little bit dizzy. 5,000 and drill like that. So you lose 500 feet every 3 turning, I think. Yeah, that's on the full development.
How
How
about
to do
the
stall recovery?
Sorry.
Stall recovery.
Stall recovery is really simple. Just push the nose down at maximum power. That's it.
Captain? How about the last accidents in Perkas?
What happened?
How about that? Is that spin?
Yeah, I think that's spin.
That's spin.
Lose control and then spin and dive. Okay. So we want to always make sure that maintain directional control. Say it. Maintain directional control, ball center all the time, and do not cross control the airplane. Cross control means when you turn left, you kick the right rudder. Then there could be
Should we do that?
cross control stall.
Crosswind.
Sorry.
So should we do that in crosswind?
Yeah, crosswind. The flying airplane flying handbook, they teach us to do yoke into the wind opposite rudder. That's actually slip the airplane. Right. There are two types of crosswind technique. The first is crabbing, and the other one is one wing low. Right. So if you do a crab, so the wind is coming from, let's say the wind is coming from this side, left side, your airplane will be like this, right? So yoke into the wind and opposite rudder. Then that's how you fly. It's slipping.
Side slip here.
Yeah. Yoke into the wind, rudder opposite. Well, that's the spin. Left turning tendency done. And let's talk about the stability. Oh, one more thing. The four forces, we call that to maintain the level, straight and level. Okay, lift will equal with weight, thrust equal with correct. So lift will never equal with drag or never equal with thrust. Lift, drag, thrust. Sorry, lift, weight, thrust, drag. That's for straight level. How about if you're climbing?
Thrust more than.
When you climb, the first acceleration to climb, the first time, that the momentum from cruise to climb. At this moment, you lift overcome the weight. After you steady climbing, like 80 knots climb, then the four forces will become same. Okay? And the airplane has its own stability. So you don't have to use your control roughly, you don't have to over control the airplane. So the new pilot always over control the airplane. Honestly, the airplane can fly without your hand because the law of inertia. Okay? This you need to remember. Then the other one is the overbanking tendencies. What's the overbanking tendencies? So when your airplane is turning to the left, it will turn to the left and even more. Why? Because when you fly to the left, right? What is your aileron does here? It's going down like this, right? And then your left aileron is going up. So when this aileron going down, let's see here. So this is your wing, and you got another tail. This is your chord line. Now your chord line has become this side, and this is your relative, and you have higher angle of attack. Understand? Okay, your aileron like this. When your aileron going down like this, then it changes the chord line. And then this is your relative wing. It's become higher angle of attack. If you got higher angle of attack, it means you have higher lift. Then higher lift will give you overbanking tendency. Okay? And remember, there's an at first, yaw. Now let's talk about the stability. Any questions so far?
For the question,
Mm-hmm.
after grabbing, what's the other one?
Sorry? One wing low.
One wing.
All right. talk about the stability. When we talk about the stability, this let's open the stability page. We have this stability.
Before.
You got something?
Wait. Slowly. Before.
It's only here.
There.
That's one.
There. Yeah.
Alright, so airplane stability and controllability. There are two types of stability. The first is static stability, and the other one is dynamic stability. If you're talking about the static stability, initial tendency or direction of movement back to equilibrium. The first is positive static stability. The initial tendency of the airplane or the aircraft to return to original state of equilibrium after being disturbed. For example, Cessna 172. And neutral static stability, the initial tendency of the aircraft to remain in a new condition after its equilibrium has been disturbed. And the negative static stability continue away from the original state of so on after being disturbed. Okay? So this is the case. So what is this? This is a positive static. This is the neutral. And this is the negative. Let's imagine if you push the ball from the left to right, what's gonna happen? It's moving to the right and stop here. Right? Moving to the right and stop. The negative stability. You push it here, it's moving and goes further. It's move away from the original position. How about the positive static?
Always back to the.
Always back to the original position. That's the static stability. Okay? The Cessna 172 is always like that. So basically you don't have to overreact it for the airplane. The dynamic stability, this is tendency to return to equilibrium that the aircraft displays after being disturbed from its trim condition. From its trim condition, it's already trimmed. So there are three items. The positive dynamic stability, the object displays return toward the equilibrium state. The neutral dynamic stability, the displaced object either decrease or nor increase in the amplitude. And the negative stability of oscillation higher. So let's see the picture. This is negative dynamic stability. I hate this. The more it's oscillating, the higher, the wider the amplitude. Got it, fam?
Not that correct.
Alright, so up, down. It's getting wider and wider, the oscillation. That's negative dynamic stability. It's like megaphone.
It's gonna.
Oscillation is getting higher and higher, bigger and bigger,
Become worse.
become worse. And the neutral dynamic stability, the airplane is like that.
The same.
It's same. And then what we want, every pilot wants is positive dynamic, this is neutral static stability. Okay, what we want is the positive dynamic stability, which is you have slower and slower and lower and lower and smaller oscillation.
So face by side.
If you have the positive dynamic stability, at the end it's gonna be straight or straight.
Yes, that's why you don't have to over control that. So we can try maximum speed, right? Maximum speed 5,000. You climb, push, right? Climb higher, cut all the power. It's going down. When it's going down, it's gaining more speed. What happened?
Going up
It's
again.
going up. Going up, no power, a lot of drag, go down. Less power, sorry, higher power, go up. So then that will be your positive dynamic stability. So you don't have to do over control the airplane because the airplane will back
What
to
makes
its original
negative
position.
dynamic stability?
Sorry?
What makes negative dynamic?
Airplane characteristic. So sometimes they intentionally make this like aerobatic pilots. They don't like positive dynamic stability. And they don't like positive static stability. They want neutral static stability. Why? Because they just want to make like a crazy maneuver and they don't want to recover. They want to the airplane stop there.
So keep going.
Keep going. Yeah. Okay.
Okay.
So this is what we call the normal stability. Then now we divided the stabilities becomes lateral and longitudinal stability. The longitudinal stability is about the pitch stability. I don't think we have here. Okay, let me find. Can you change to Apple TV, please?
Yeah.
Screen recording.
Okay.
Oh, bisa bisa. Iya. Jadi record aja dari iPad.
Alright guys, we are recording the screen from iPad. Unable to connect. What happened? Unable to connect.
The Wi-Fi.
Network. Network here.
Disconnect.
All set. Oh, okay. Got it. Different Wi-Fi.
Oh.
Alright, we are using Apple TV here, guys, so we connect everything from iPad to our TV. So, does it work? What is the internet name there?
Internet Astrology. Just Astrology.
Alright, I cannot connect this. What happened? Maybe you change the other one to Astrology 3. Change the Wi-Fi. Weird.
There's not a Wi-Fi.
Okay.
What Wi-Fi that you use?
It's Astrology.
Wait, how about in airplane? Airplane on. That's
There we go. Woo. Alright, so this is longitudinal stability or pitching stability. Longitudinal axis actually is roll, but when we talk about the stability, it's become pitch. Longitudinal stability is a quality that makes an aircraft stable on the lateral axis. It involves the pitching motion as the aircraft nose moves up and down in flight. To obtain static longitudinal stability, the relation of the wing and tail moments must be such that if the moments are initially balanced and the aircraft suddenly goes up, the wing moments and tail moments change so that the sum of their forces provides an unbalanced but restoring moment, which in turn brings the nose down again. So here's the key. If you see the airplane here, alright, take a look. So the airplane design, they always put the center of gravity in front of the center of lift. Always. Why?
To make it balance.
No. The center of gravity is when the weight is centralized from the airplane. So why they put the center of gravity in front of the center of lift?
Because in the tail, we are
Because we want to do a nose down tendencies. Because the nose down is better to break the stall. Right? And
because the tail.
the tail here is also downward. So when you have center of lift, how to balance that? You have the downside movement from the tail.
From the tail and from the
Yeah. So there's a downwash from the upper wing go to the tail to give
down.
tail down pressure. So what happens if the tail is get a down pressure? The pitch will up. That's why the balancing is using the CG will push equalize the pressure. So when the airplane suddenly go up like that, then the center of gravity will put the nose back to the moment of we call that the moment of stability, right? Then the pitch will be stable. Then if you suddenly get nose down tendencies, then the higher the airspeed, the more the airflow here will put the downside movement from the tail, then there will be a nose up. Fully understand?
Yeah.
Excellent. All right. So the other one is we talk about the lateral stability. There are two types of lateral stability here. The Cessna and the Piper is quite different. The high-wing airplane is using the principle of pendulum. So if you're flying like this, you see the pendulum,
Yes. Oh,
okay? Then you're flying like this, the pendulum will go back here and put the airplane back to the normal state. And the other one is using diagonal. So if you see the diagonal, it's pretty much different. Since the low wing, normally this is the wing here, the airplane when it turned, okay? So the wing is never flat. The wing is always make an angle here. This angle, we call that diagonal. But if you know the airplane like British Aerospace 146, we call it anhedral. Why? Because the airplane has a high wing. You see that? This is the engine. And the wing is going down. So that's anhedral. So this dihedral, because the wing is bent upside, so the lower wing get more angle of attack because this is the relative wing compared to this side. So this angle of attack, it means more lift. Okay, let's say you have a dihedral wing here, then this side get greater angle of attack because when it turns, it's coming from this side compared to this side. Okay, you get more angle of attack, then the airflow will kick the wing back to normal. So that's what we call the lateral stability or roll stability. You get it? So what kind of stability that we have? The pitch stability. We are talking about when we put CG in front and then the horizontal stabilizer. We're using this to do the pitch stability. And then when we talk about the roll stability, we have the principle of pendulum on the high wing and the dihedral effect. Okay? Any question? And the other one is the yaw stability or vertical stability is using the fin. The vertical stability is to prevent the airplane yawing like that. But the examiner will ask you about dihedral and the pitch stability or roll stability. Okay, we talk about stability, we talk about drag, left turning tendency, spin, four forces. That's it. That's all the aerodynamics subject that you should know, and they will ask you about all the aerodynamics from lift until drag and four forces and lift to drag ratios, okay, and stability, left turning tendencies, and that's all for aerodynamics. So your private pilot or commercial oral exam will be like 3 hours, but it's not cover the whole aerodynamics. They will ask you like very important point like stall spin, why stall happen, and why spin happen, the type of spin. Then if you can answer that right away, you're good to go. Next chapter. So maybe talking about the engine systems and so on.
Every chapter or just what they want?
Another.
Based on the ACS.
Oh,
So we need to prepare you line by line based on the ACS. Then after you study, you hear from me, then now your turn to come here in front of the class and you do your presentation. If you can do your presentation very well, nail it, and be a second nature, no matter who is your examiner, you will pass your check ride. I believe in that. Alright? Any question? Alright, so that's all the aerodynamic. Thank you very much for watching. Subscribe and share this for your friends who want to become a pilot. Thank you for joining for the Pilot Flight Academy. See you on the next video.